So in this video we're gonna see what a diode does to a AC input. So this is my input. It's a sine wave from 0 to 7 volts out of the frequency of 50 Hertz, and this is the diode that I chose, and then it's connected in series with the load of 1K. So let's see my supply, and this is my AC signal from 0 to 7 volts, and then during the positive cycle and during the negative cycle it goes from 0 to minus 7 volts. Let's see the voltage here. Well, my diode only conducts during the positive half cycle of the input, as it can be seen here. It only conducts during the positive half of the cycle and remains zero during the negative half of the cycle. And to see here, there's a small difference between the input signal and the voltage after my diode. You can see a small drop of 0.7 volts. That's a drop across my diode. And this behavior of the diode creating a signal that is only available during the positive cycle of the input is called rectification, and it's used to convert the AC signal to a DC signal. And this is a half rectified signal, as the diode only conducts for the positive half of the cycle, as seen here. So I have set up the same configuration as seen in the simulation. I have a diode connected to a 1K resistor, and this multimeter is measuring my VCC. It's at 6.8 volts, and I'm using an auto transformer to down convert my 240 volts to 6.8 volts, and I have my oscilloscope here. I'm measuring two signals. First one is measuring my VCC, and the second one is measuring my halfway rectified signal. And let's check the frequency of my input. So at this setting you can measure the voltage as well as the frequency. So it's at 49 Hertz. Let's check if it's the same here. So my section division is at 10 milli, and so I'm checking for one period. So one period starts from here and ends here, so that's 10 millisecond, 20 millisecond, and my frequency is equal to 1 over time period, so it's 1 hour 20 milliseconds, and that's 50 Hertz. And as you can see here, this is my 6.8 volts input supply, and my rectified signal looks like this. It's this signal. And if you want to see it more clearly, I can displace my those signals, and this is my supply, and this is my rectified output, supply and rectified output.